Today's problem is LeetCode 16, threesome closest. You are given an integer array called nums with length n, and an integer target. Your task is to pick exactly 3 different numbers from the array such that their sum is closest to the target value. Unlike the classic threesome problem, here, the sum does not need to be exactly equal to the target. You only need to return the sum, not the indices or the triplet. You are guaranteed that there is exactly one closest solution, so no ties to worry about. The challenge is to find the triplet whose sum has the minimum absolute difference from the target. Our goal is to solve this efficiently, without checking every possible combination. In this video, we'll break down the intuition, use a smart two-pointer strategy, and arrive at an optimized solution step by step. Let's understand the problem using example 1. We are given the array -1, 2, 1, -4, and the target value is 1. Our goal is simple. Choose any 3 numbers whose sum is closest to the target. Step 1. Sort the array. First, we sort the array to make searching easier. After sorting, the array becomes -4, -1, 1, 2. Sorting allows us to use the two-pointer technique efficiently. Step 2. Fix the first number. We start by fixing the first number. Let's fix -4 as the first element. Now we use 2 pointers. 1 pointer just after -4. 1 pointer at the end of the array. So our triplet starts as -4, -1, and 2. Their sum is -4 plus -1 plus 2 equals -3. This sum is far from the target one, but we record it as our current closest sum. Step 3. Move pointers to get closer to target. Since the sum is less than the target, we move the left pointer to the right to increase the sum. Now the triplet is -4, 1, and 2. The sum becomes -1. This is closer to the target than before, so we update our closest sum. Step 4. Fix the next number. Now we fix the next number, -1, as the first element. Again, we use 2 pointers. 1 at 1, 1 at 2. The triplet is -1, 1, and 2. The sum is 2. Now compare it with the target. Target is 1. Current sum is 2. Difference is just 1. This is the closest sum we've seen so far. Step 5. Final answer. After checking all valid combinations, the closest sum to the target one is 2. So the final answer is 2. Let us first clearly understand what the problem is asking. We are given an integer array and a target value. Our task is to choose exactly 3 different numbers from the array such that their sum is as close as possible to the target. Important point here. We are not required to match the target exactly. We only need the sum that has the minimum absolute difference from the target. And the problem guarantees that exactly one answer exists, so we do not need to worry about ties. Now let us think about how we could solve this. The most straightforward idea would be to try every possible triplet and compute their sums. But that would require 3 nested loops, which gives us a time complexity of n cubed. That approach is far too slow for large inputs, so we need a more efficient strategy. This is where sorting becomes extremely important. The first thing we do is sort the array. Why do we sort? Because sorting allows us to use the two-pointer technique, which helps us intelligently move through the array instead of blindly checking all combinations. Once the array is sorted, the numbers are arranged from smallest to largest. This gives us control over whether a sum increases or decreases by simply moving pointers. Now let us walk through the main logic step by step. After sorting, we use a loop to fix one number at a time. Think of this fixed number as the first element of our triplet. For each fixed number, we now need to find 2 more numbers such that the total sum is closest to the target. To do that, we place 2 pointers. The left pointer starts just after the fixed index. The right pointer starts at the end of the array. So at this moment, we have 3 numbers. 1 fixed number, 1 from the left pointer, 1 from the right pointer. Next, we calculate the sum of these 3 numbers. Once we have the sum, we compare it with the target. We calculate the absolute difference between the sum and the target. If this difference is smaller than any difference we have seen before, we update our answer. This step is crucial because we are always tracking the closest possible sum. Now comes the most important decision-making part. If the current sum is less than the target, what does that mean? It means the sum is too small. To make it larger, we need bigger numbers. Since the array is sorted, the only way to increase the sum is to move the left pointer to the right. So we increment the left pointer. If the current sum is greater than the target, what does that mean? It means the sum is too large. To reduce it, we need smaller numbers. So we move the right pointer to the left. This is the key advantage of sorting. With just one pointer movement, we can control the direction of the sum. We continue this process while the left pointer is still less than the right pointer. Each time, we calculate the sum, compare it with the target, and update our closest result if needed. Once the two pointers meet, it means we have exhausted all valid pairs for the current fixed number. Then we move to the next fixed number and repeat the entire process again. By doing this, we efficiently explore all valid triplets without unnecessary calculations. Why does this work? Because for every fixed number, the two-pointer technique guarantees that we check all possible combinations of the remaining numbers in a sorted and controlled manner. Instead of O(n) cubed, this approach runs in O(n) squared time, which is efficient enough. At the end of the loop, we simply return the stored result, which represents the sum of three numbers that is closest to the target. And that completes the solution. To summarize the flow: sort the array. Fix one number. Use two pointers to find the best pair. Adjust pointers based on comparison with target. Track the closest sum throughout. Return the final result. This combination of sorting and two pointers is a very common interview pattern, and mastering it will help you solve many similar problems. All right, logic is complete. Let's hit run and verify with the sample test cases. Looks good, outputs are matching perfectly. Now submitting the solution. And boom, accepted. All test cases passed successfully. That's how you solve the three-sum closest problem efficiently using sorting and two pointers. If this explanation helped you, hit the like button, subscribe for daily LeetCode solutions, and drop a comment if you want a visual walkthrough or animation for this problem. See you in the next one. Happy coding!